Hi you guys, this is Miss Pruitt and I wanted to do a lesson with you guys really quick about the chain rule. This is actually the quick lesson, part 1 of what might be 3 different parts. Here are the different ways that we can solve the chain rule problems, but basically we're just doing the derivative of the outside function multiplied by the derivative of the inside function. So let's do an example. Number 1, I want you to differentiate f of x equals x cubed plus 7 quantity cubed. So f prime, or the derivative of f, I'm going to identify my outside function. My outside function is the power of 3. And my inside function is the x cubed plus 7. So I'm going to take the derivative of the outside first, leaving the inside completely alone, and then I'm going to multiply it by the derivative of the inside function. So in that case, this will be 3 times x cubed plus 7 squared. That's me taking the derivative of the outside function and multiplying it by the derivative of the inside. And derivative of x cubed plus 7 is 3x squared. So combining that together, this 3 times 3 is 9. It's 9x squared, x cubed plus 7 squared. And that's the final answer. Moving right along to the next problem. F of x equals cosecant of 3x divided by 5. So if I'm going to take the derivative, I'm actually going to, well, before I even take the derivative, let's erase that. Before I take the derivative, I'm going to rewrite this. This is the same thing as 1 over 5 times cosecant of 3x. All I'm doing is pulling that 5 in my denominator out and making it 1/5. So now let's take the derivative. Taking a derivative. I'm going to leave this on the outside and worry about taking a derivative of these functions. And by the way, I see one function right here. I see another function right there. It's a function inside of a function. So I'm going to take the derivative of the outside function first. Well, the derivative of cosecant is negative cosecant, but I leave the function that's inside of it alone times cotangent of the inside function, leaving it alone. Now I'm going to multiply it by the inside function. So I'm going to multiply by, sorry, I'm running out of space, multiply by 3. Okay. So combining everything together then, that's 1/5 times negative 1 times 3. So that's negative 3 over 5. Cosecant 3x, cotangent 3x. And that's my final answer. Alright, next let's do one where there is a product rule that is involved. And in this one, I'm going to show you kind of like a little trick. So I recognize that this is one function and this is another function. So it's requiring me to do the product rule first. I'm also recognizing that this is a function within a function because it is equivalent to 2x minus 3 to the 1/2 power. Okay. Here's a little trick though. Alright, so what you do is you draw a line right here and you draw a line underneath. So looking up here at this x, I want to know what its derivative is, and the derivative of x is 1. Next, I'm looking at the square root of 2x minus 3, and I want to take the derivative of that. The derivative of that would be 1/2 times 2x minus 3 to the negative 1/2 power. But that's just taking the derivative of the outside function. Now I have to take a derivative of the inside function. And the derivative of 2x minus 3 is 2. So here's the little trick. What you do is to find a derivative, now that I've taken, I guess it's not a trick, I guess it's just another way to set it up, is you multiply kind of across, similar to I guess how you guys do cross multiplication. Like, let me pick another color. Multiply that with that and that with that. So if we do that, first let's multiply this times this. I would get, first of all, these twos cancel. I would get x over the square root 2x minus 3. See that? And multiplying across there to there, I would get plus 1 times the square root of 2x minus 3 is just square root of 2x minus 3. Sorry, I was trying to extend that. Square root of 2x minus 3. And I will take that as an answer. But just like in class, if you want to be fancy, you would find a common denominator and multiply the top and the bottom by the square root of 2x minus 3. You would get that x plus 2x minus 3 is over the square root of 2x minus 3. And so your answer would be 3x minus 3 over the square root of 2x minus 3. And I would take that as an answer as well. So let's do the same trick again. Because I'm noticing that I have a function, which is x squared, that I am multiplying multiplying with another function, which is sine of 2x. What you can do is draw this and draw that. And then you take the derivative right underneath it. I'm just trying to pick another color. So the derivative of x squared is 2x. And the derivative of sine of 2x. Now, look, you have a function. You have a function within another function. So doing chain rule, I know I'm going to take the derivative of sine first. So it's cosine of 2x times the derivative of the inside, which is 2x. The derivative of 2x is 2. Then do what we just did, where you kind of multiply across and add them together. Cross multiplication, maybe? In a way. 2x times sine of 2x. I think I'm going to go with my x squared first. I'm going to go in this direction. I'm going to do the 2 times the x squared times the cosine of 2x. So it's 2x squared cosine of 2x plus, now I'm going to multiply these two together, the 2x times the sine of 2x, and simply just put 2x sine of 2x. Alright, you guys, last problem of the night. Find the equation of the line tangent to the graph of f of x equals x times x minus 2x, and all of it is cubed at the point 1, negative 1. Alright, so if I'm looking for the equation of the line tangent to the graph, I need to find out what my slope is. How do we find slope? The derivative. So let's take the derivative of this. I'm recognizing that I have a function times a function in a function. It's pretty awesome. So my outermost function, my outside function, is the power of 3. So let's start there. Taking the derivative. Let's prove it. So taking the derivative of the outside, leaving everything else on the inside alone, that would be 3 times x times 1 minus 2x squared times the derivative of the inside. Well, I'm going to have to do product rule because this is a function times another function. Product rule says you do the first times the derivative of the second plus the second times the derivative of the first, which in this case is just 1. Okay, next. Because I'm running out of room, I need to come over here. It's telling me to evaluate it at the point 1, negative 1. So I'm just going to evaluate at x. There's no need to start combining at this point. That's where you could probably mess up, and I don't want you guys to mess up. Just plug in your x value. So this is 1 times 1 minus 2 times 1 squared times, well, 1 times negative 2 is just negative 2 plus 1 minus 2 times 1 is 2. So cleaning this all up, this would actually be 3. This is 1 times 1 minus 2. Which is negative 1. Negative 1 squared is just 1. Then I have negative 2 plus 1 minus 2. Which of course is negative 3. So I'm going to multiply this by negative 3. And so I find out that my slope is actually negative 9. But I am not done. I'm asking for the equation of the whole line tangent to this function. So of course we go then to point slope form. Point slope form is y minus y1 equals m times x minus x1. So if I plug that all in, plug in what I have my point x and y, gave it to me there. I will have y minus negative 1 equals my slope. Did I just put 9 here? I apologize, you guys. Negative 9. Point, right? Negative 9 x minus 1. And of course, you can make this much more pretty because your two negatives make a positive. So it's really just, if I have enough room, y plus 1 equals negative 9 of x minus 1.